session on how the region of Peel has been able to analyze over 10 years of maintenance history to support the management of their water system to deliver safe, reliable water to their customers. My name is Bill Grant, and I will be the moderator of today's webinar. Martin Pendlebury from the region of Peel will be talking about how they are using the information to support their water management services and the key performance indicators used to measure how effective they are in their program. Chaim Schwartz has worked with the team in Peel using Esri tools to analyze 10 years of maintenance history of water main breaks to support the work that Martin and his team are doing. Chaim will be showing the results of this analysis. But before we get into our session, I want to show you what Esri Canada has just released in supporting our users and the community at large with the software, services, and materials that are helping people understand, manage, and communicate the impact of the COVID-19 outbreak. These resources are being curated by the Canadian and global health community to use and share as the pandemic unfolds. We can also support you and your organization develop similar hubs for your needs in your areas. This GIS hub is a collection of data, maps, applications, and other resources available to you and the public to assist in monitoring, preparing for, and responding to the rapidly changing situation. This hub can be leveraged to map cases, the spread of the virus, vulnerable communities, or critical assets such as your facilities, your workforce, equipment, and services that are available to support the battle against the COVID-19 and help communicate your organization's work with interactive maps and dashboards. To improve the quality and quantity of information on this hub, we are asking for your support in providing information that would be valuable to all of our customers and citizens. If you are not sure of what data to provide, please complete the form on the website listed below or contact me or your Esri Canada account manager for assistance. Remember, you will be getting a copy of these slide decks, so you'll be able to get this information once you receive that. So moving forward with the webinar today, here are some housekeeping items to be aware of. We will record the session and provide it to all who are attending the webinar, along with the written answers to your questions. To better serve you on future webinars, please take the time to complete the survey that will be included with the email. This will help us in developing better future webinars. If you have any questions about the content we're presenting, please use the Q&A panel. Be sure to choose Ask All Panelists, type your question in the box, and click Send. We'll take questions at the end, but feel free to type your question in anytime during the session. Today's webinar will focus on these two topics. First, Martin will review how the region of Peel developed their new KPIs for measuring how they are providing services to the water customers in the region of Peel. There's been a big push from senior management and council to look at KPIs in relation to service to the customer, and Martin has developed some new ones for the region. Then Chaim will review how he has used ArcGIS Insights to analyze the vast amount of data collected over the past 10 years and how work history data is merged with other GIS data that impacts the maintenance of the water assets. In order to set the stage for today's session, this slide shows how there's a continuous link between the maintenance management system where all of the repair history is collected and your ArcGIS platform with all of its tools to support the analysis needed for all of this data. From a maintenance perspective, it's important to make sure you are collecting the information needed to report on any key performance indicators. Things like the start and end dates of a job, the cause of the repair. The resources used, both internal and external, are examples of what needs to be collected. You can then bring in the strengths of the ArcGIS applications to perform the various analyses needed. Here you can use additional data that is not collected in the maintenance management system. For example, pipe diameter, pipe material, the soil types, even electoral boards. It is merging maintenance data with GIS data to support your infrastructure renewal program and evaluate your adherence to your maintenance programs. This is what the region of Peel has done to support their programs to deliver safe water to their customers. I will now turn the presentation over to Martin Pendlebury from the region of Peel.
Thank you, Bill. Thank you, everyone, for joining us today. I know everyone has a lot of other priorities at the moment, so it's good of you to be with us. So, as Bill said, I've spent some time over the last couple of years looking into water main break our data and the history of that data, I'd like to share with you some of the things that we found at Peel and some of the things that we've done to try to look at our service we provide from more of a customer-oriented point of view. So I'm just going to first of all talk about the region of Peel for anyone who doesn't know much about Peel and its water supply system. Then I'll get into that historical main break data and analysis. And then I want to talk about reliability of water supply from a more customer-oriented point of view. And then I'll go through a process that we developed at Peel to determine the population impacted by main breaks using GIS, which allows us to calculate these KPIs, these metrics, which we couldn't do before. And that's led to new service levels, which are customer-oriented. And then I'll get into what's next, where we go from here, and I'll hand it over to Chaim to talk about other tools that he wants to show you to analyze this data. So the region of Peel is a large municipality. We are in southern Ontario. We border on Lake Ontario, just west of the city of Toronto. Growth in Peel has been steady since its inception in 1974. Today, we have just under 1.5 million residents and more than 175,000 businesses in the lower tier cities of Brampton, Caledon, and Mississauga. We are the second largest municipality in Ontario after Toronto, and we are forecasted to grow to 2.2 million residents and nearly 1 million employees by 2041. Water supply in Peel is provided, people either get the water from private well, in a few cases, municipal well systems up in Caledon, or in most cases by water from Lake Ontario. We have two large water treatment plants in the region, AP Kennedy and Lauren Park on the shores of Lake Ontario. Those plants and the transmission system is operated by the Ontario Clean Water Association on behalf of Peel. We produce, on an average day, about 575 million liters of safe, high-quality drinking water. We also provide about 110 million liters a day of drinking water to York Region. So in 2019, we produced about 210 billion liters of water, which is about 84,000 Olympic-sized pools. So as I said, we have two water treatment plants, lake-based, 13 pumping stations, 12 reservoirs, 4 elevated tanks, and 4 independent municipal groundwater systems up in Caledon. Our distribution system is almost 4,700 kilometers long. Its average age is 23 years. We have 7 main pressure zones, 9 subzones, and those 4 well-based systems. We service a population of almost 1.5 million. Almost 750,000 employees work in Peel, which equates to about 315 residents per service per kilometer. Our network has changed in nature over the years. Back in the mid-90s, we had a lot more metallic mains. With the growth in Peel and with an aggressive replacement program, we now today only have about 10.5 to 11% of metallic mains left in the system. 68% of our system is PVC. And that has implications, as you might imagine, on main breaks. So switching gears then to water main break data, our operations staff have been collecting water main break data for the past 25 years at least. They use an electronic form these days, which I'm showing you here. They collect the typical information you might expect, like the date and location of the break, the asset ID, the diameter, the depth of the water main, the failure type and cause, the material of the main, the soil type, and recently, in the last couple of years, they've also been collecting information on the valves they close to isolate the area to fix the main break. And from that information, you can get a sense of how big the area is that you're closing, and with the off and on, the duration of the impact to those residents. So we've been talking to our operators and trying to get them to understand how important it is that they collect this data fully, and carefully. Data quality has improved over time, and it will continue to improve. We are going to be moving shortly to a GIS-based system to collect this data, which will cut down on any errors with the collection. So, based on this data, we've done a lot of what I would call standard, typical kind of analysis. We've looked at total breaks in Peel over time. Back in 2010, we were over 300 breaks a year. Last year, we had 135 breaks. So we can see a definite improvement, and that's gratifying to see, because that says that our replacement program is doing its job. When we look at breaks from a point of view of length of system, breaks per 100 kilometers, we look pretty good. We've dropped from 7.6 to 2.9 breaks per 100 kilometers over the last 8 or 9 years. That's a drop of about 2/3, which is quite good, considering that the North American average over a similar time frame has gone up by 28%. We looked at breaks per 100 kilometers based on material. PVC and CPP are down around 1.3, copper at about 2.2, AC at 15, DI at 24, and CI at 29. So you can see how the material makeup of our system is beneficial to us from a point of view of main breaks. We've done a lot of other analysis, which I won't show it today, but on breaks by month of the year, by day of the week, by pressure zone, year installed, age of the water main. A lot of good information there, but all of this analysis is asset-centric. It doesn't really look at the customer. So, as Bill alluded to, Peel now has a strategic plan. It's been 5 years now. It's been in place, and it's split into 3 areas. Living is about people's lives and improving those lives in their time of need. Leading, which is a government that is future-oriented and accountable. And thriving, which is about communities that are integrated, safe, and complete. That is where water supply comes in. And our mandate for water supply is to provide a safe, reliable, and high-quality drinking water throughout the region. We ensure that our water meets or exceeds Ontario drinking water standards and is continuously monitored. Now, I think it's safe to say that at Peel and most utilities, safety of that and quality of that water is pretty good. There's really nothing to be concerned about. We do tens of thousands of samples every year to ensure that quality is good. Reliability is something that maybe we don't have as good a handle on. We think we do provide a reliable service, but how do we know that? How can we show that? So we have a number of performance metrics under water supply in our strategic plan. One of them I'm showing here is water main breaks per 100 kilometers, and that's a useful metric because a lot of utilities measure that, and it's a way to benchmark. But again, it's asset-oriented. What we're missing is a reliability performance metric that is customer-oriented. So reliability of water supply, safety and quality are obviously are paramount, and that comes first, obviously. But reliability of that supply, that service that we provide, is where the value is truly created, I think. And so I was racking my brain how could we come up with a way to measure that reliability that's more customer focused. And I thought about other utilities, other types of utilities, and how did they measure reliability. And I thought, well, water supply and power supply have a lot of similarities. There are a lot of differences, but a lot of similarities. And I thought, well, how do they measure reliability? So I started looking at their websites, and it's common that for a power outage, you'll have a tool online you can go to and find out, people impacted by that outage, the extent of it, the duration, when it will be back online. Water main breaks, there's rarely any estimate of population impacted or the duration or the area of impact. And only a few utilities I've found that have actually online tools with some limited information about the outage. So the power supply industry, they use a suite of indices that the IEEE has developed over the years, and I'm going to walk through a few of them here. I know there's a lot of math in this slide, but these are ones that I think could be applied to water supply. The first one is the System Average Interruption Frequency Index. This is the number of interruptions that a customer would expect to experience in a given period. Next is the System Average Interruption Duration Index, the duration of interruption for an average customer in the year. So that's kind of the expected value. If you're a customer of a system, the duration, total duration spread across the service population. The Customer Average Interruption Duration Index is about average time to restore service to customers that actually been impacted after a break occurs. The next one is the Customers Interrupted Per Interruption Index, average number of customers that are interrupted for each interruption. And finally, the Average System Availability Index, which is really the ratio of the duration the service was available to all customers to the total duration of service for that time period. Now, you'll notice that all of these indices use the same four variables: the number of unplanned interruptions in the year, the duration of each unplanned interruption, R sub I. N sub T is the total service population, which we know. N sub I is the population impacted by each interruption, and that is something we don't know. So at the region of Peel in 2019, for these variables, we know N sub T. I covered that earlier in the presentation, that 1.5 million residents and almost 750,000 employees. We know how many water main breaks we had in 2019, 135. We know the duration of impact because of the valve closure information. The one thing we don't know is how many people were impacted by each water main break. So how can we determine this? So I'm going to walk through just quickly the process that we developed at Peel to estimate that population impacted. So we start with the census information. We do this with our planning already for our master planning and other purposes. We spread that population across the region to over 1,000 what we call small geographic units. These are on average 115 hectares in size with an equivalent population of just under 2,000. This allows us to get down to a more granular level. Then for each SGU, we just distribute the population to the parcels based on land use and water billing data. And this allows us to distribute the entire population of Peel at the parcel level with some certainty about the numbers. We then use GIS to create what we call multi-part water main segments between isolation valves. So normally for a water model, you break the system at nodes and where pipes change material or size, that kind of thing. Here we want to create water main segments based on between the isolation valves. We then assign, in step 3, all the parcels to those water mains using, if they are available in GIS, the service lines, and if not, we use GIS processes to assign the parcels to the appropriate water main. This is all done ahead of time. Now, step 4, well, locate the break when it occurs. Then, using the valve information, we can identify the area isolated to repair that break and identify which segments are within that isolation area, and then sum up the population impacted by those segments. So what can these reliability indices tell us? Well, for the one that is, I think, the most useful is System Average Interruption Frequency Index, which is the number of interruptions a customer expects to experience each year. Now, that's that's good for power supply because often people experience more than one outage a year. For water supply, because water main breaks are less common, this really is the percentage of the service population that's impacted by water main breaks. So in Peel, you can see there on the chart on the upper left is that this has dropped from 3% of the population in 2011 to less than 1% in 2019. Interesting, the inverse of that index is really the water main break return period, and this has averaged for the last 5 years at 73 years. A couple other of the indices, like the customers interrupted per interruption, has ranged between about 150 and 200 per break. This is equivalent population. And also the customer average interruption duration index, which is the length of time people would likely be out of water, has ranged from about 5 to 9 hours over the last 10 years. So in Peel in 2019, a few things that we can say based on these indices. 0.9% of the population was directly impacted by breaks. The average interruption across the population was 3.6 minutes. The average duration for people who were actually impacted was 6.7 hours. 147 people or employees were impacted by a break on average. Potable water was provided to all residents for 99.9993% of the year, which is pretty much all the time. And based on that return period, a typical Peel resident might never experience a break. That's not something I would likely publish, but it's useful information for us to know. So based on this analysis, in 2018, Peel added 2 service levels based on water supply reliability. We enshrined the breaks per 100 kilometers metric, which we had always referenced, but we had never actually had it as an official KPI. And we also included the percent of service population impacted by unplanned interruptions. And again, this is the probability that a resident Peel will be impacted by a break in a given year. We haven't established a target for this. We may do that. At the moment, we're just monitoring it. And we may employ additional service levels, maybe based on duration as well. That's still being discussed. So circling back then to our strategic plan, Peel has a dashboard of across the whole corporation of areas of service and metrics based on those. And the 2 that we have here for water main breaks is our water supply. Related to breaks is the impact of the breaks on the population, percentage of service population in Peel impacted by water main breaks, and the breaks per 100 kilometers. Now, this has not been updated for 2019 yet, so that you'll just see the 2018 data there. So just to wrap up my part of the webinar, we now have Peel a new way of considering reliability of water supply. This, of course, is a direct impact of the main breaks on the public, not the general disruption to the public, like road closures and that kind of thing. We have developed service levels based on this. More may be coming. One thing we'd like to get to one day is having an online tool, just like power supply and utilities do, to give information to the public in real time. There's a lot of the hoops to jump through before we can get to that, to automate this process a bit more, and but that's where we'd like to go eventually. We're still doing further analysis on the data to glean more insights from it. One of the things that is top of mind is the fact that because so much of our system is PVC, we really want to understand more fully how PVC pipes break, when they break, how long will they likely last. That's going to be a big issue for us in the future. But I think we're reaching the limits of what we can do with some of the current tools we have and methods. So we're really looking for some other ways of analyzing the data, maybe linking directly to our databases rather than using exported data, that kind of thing. So with that, I'm going to turn it over to Chaim Schwartz to talk about some of the tools that Esri has to further the analysis that we've started.
Thank you, Martin. So we sometimes like to describe the role of a GIS system as a system of systems, and I think the great work you just demonstrated now, your and your team's work, really encompasses these three different systems. So the first system is the system of record, and it is that foundation that you already built, where you record your water mains data, your work and maintenance records, soil data, demographic data, and more. And then on top of that, you built your system of insights. You analyze the physical characteristics of your failing water mains, the historic work records, and the impact these failures had on your customers. And then you took that additional step towards the system of engagement, which is about communicating all that great data and insights internally and externally. And you showed how that's being done today with the new KPIs that the region is now tracking and sharing. What I'll show next is work we did with your team and your data using ArcGIS Insights. This was a joint effort to see how we can replicate some of the work that you have done using an analytic GIS-centric tool and perhaps take it one step forward. So what is ArcGIS Insights? ArcGIS Insights is an analytic tool that allows you to access geographic and non-geographic data, explore, analyze, and visualize it in an interactive way. I'll start with a quick example from scratch to demonstrate how we work with the region's data, and then show some of the additional examples that we've completed. So this is a blank new Insights page, and I've connected to the GIS and the work orders from the Enterprise Work Management System that you've shared with us. And the way it works in Insights, once you've connected to your data, you can see all the attributes, all the fields that you store and record with your water mains in this case. And what I could do now is I can choose one of those fields, such as diameter, and drag it onto my page and create a new card. It can be a map, a chart, or a table. Let's create a map. And this will create a map of my water network. And because I chose the diameter, it will now symbolize my water network based on diameter. On top of that, I can also add my work orders as a point layer. And what I'll do is I'll change that into a heat map to make it a little bit more meaningful. And this allows me to now view my water main break records from a work management system on top of my GIS. To actually create that connection between those two, what I will do is I'll create a relationship between my GIS and my work orders. And I'll do that based on that join field. So that's the asset ID. And creating that connection now allows me to actually build these cards, taking data from both my GIS and the work maintenance records. And I can do things like choosing the material and showing the number of breaks that I have per material. Or maybe I want to change that to a different chart type and choose a tree map. I can also take the date of break repair and create a time series. So Insights prompts me to choose the relevant type of charts. And if I now enable cross-filtering, what I can now do is choose and see that most of my breaks are happening in ductile iron, in cast iron, and PVC. And I can choose one of those, such as cast iron, and I will now see the cast iron portions of my water network, breaks happening on my cast iron network, and the trend over time. So this was a quick example just to see how we work with maintenance records and GIS records in Insights. And from here, I'll walk through 3 different example pages that we created. So this first page was created to provide an understanding of which assets are failing, where and when, and how customers are affected by it. And really, to a larger degree, this is replicating what Martin already showed and Martin and his team did, and just using the great data that they already produced. The main advantage of building it with a tool like ArcGIS Insights is that you're able to connect directly to your authoritative records. So we've got our water main network here. If I turn the brakes, I'll see that most of the system is red, which is my PVC, so that's the newer non-metallic mains that are being installed. And we can see the cast iron orange mains and the ductile iron green mains, which are being removed over the last few years. Having this allows me to select different combinations and look where my cast iron breaks and mains are. And if I chose cast iron, I will now see how the diameter, which types of diameters fail, how they play over the months of the year. What's the pattern over the different months of the year? And what are the typical soil types that are related to my clay failures? And I can choose my ductile iron to see how that is different or similar. So maybe we're still seeing a similar kind of smaller diameters breaking, but a very different type of pattern over the years in soil. And I can filter that by any number of combinations by year and other parameters that I can add here inside filters. But then, as Martin explained, one of the region's main focuses was understanding and tracking the impact on customers. So we just took that great data that Martin's team has worked on and added it to this Insights page. The 2 cards on the left here are showing 2 of the parameters and KPIs that Martin was referencing earlier. So we can see the duration of disruption by year. We can see how that changed. How much time does it take us to fix one water main break from start to end? And we can start asking questions. So why is this changing, decreasing, or increasing over time? We can also see the number of affected customers and the customer hours, so the total customer hours, and how that is changing over the years. Now, because this is all interactive, what I can now do is I can choose to maybe look at this from a more political, ward-centric question and ask questions like, okay, what's happening in Mississauga, Ward 5? Now let's enable the cross-filtering over here, which will allow me to show specifically for the ward that I'm interested in, the locations of breaks and the patterns. So all these patterns are now auto-filtered to show only relevant information to my ward and how that's changed over the years. And I can then very simply compare that maybe to a neighboring ward and see how different or similar the behavior of records for that ward have been over the years. So this is kind of an overview page that allows me to understand where, how breaks are happening and how that affects customers. But then we went in the second page over here to answer a different question. And we said, let's take a look into the past and understand how our replacement program has been behaving over the years. How effective is our replacement program? So on the graph here on the left, we can see the total kilometers of pipes in the ground by year. And the red graphs, the red is PVC. We can see that we're putting more PVC in the ground over the years. And then we can see how the green ductile iron are being removed, as well as the cast iron that are being removed from the years. Actually, I've got that filtered. So here we can see the ductile iron that is being removed, the cast iron that is being removed over the years. This graph over here on the right shows the same thing. The gray bars show the total kilometers of pipe, and the red line shows the failure rate over the years. So the number of breaks over the years. Now with these two graphs, when you add the interactivity built into the filters that you can add, you actually have access to a large amount of combinations that you can now drill down into to ask questions about different sets and cohorts of diameters and material and so on, without the need of actually recreating all those in such as what we'd be doing with a tool like a spreadsheet program. So you can say, okay, what's happening with my cast iron? I can see that I'm removing cast iron over the years, and I can see how beautifully the red line, the failure rate, decreases over the years as well. I can choose the ductile iron and see, and this is actually an interesting one because you can see how as ductile iron was removed from the ground, it took several years until the impact could actually be achieved. And that can be ascribed to backlog. But then you can see how in the last 10 years that impact and the decrease in failure rates can be very easily shown. However, you can get into a more detailed level and ask, okay, how is this working for my 150 water mains? And it works pretty well. You can change that into a 300 millimeter and say, okay, we are removing 300 millimeter mains, but am I seeing that decrease in the number of breaks? I'm not sure anymore. So should I keep replacing those 300 millimeter mains or put more effort on the smaller diameters? Insights doesn't answer these questions for me. Rather, it allows these kinds of questions to surface, which otherwise would be buried in the data. And granted, there are many other reasons to make final decisions on which pipes you replace or do not replace. But this tool gives you a way to look into the effectiveness of your final decisions in terms of failure rates. And then the last page, this third page, was built to answer a third question. And that question is one of the fundamental questions when you try to optimize your replacement program. And that is the expected life of your assets. Now, in the case of water mains, defining the end of life or expected life is to a large extent up to us to accurately define. Do we define it as the first time a water main breaks, or can we actually tolerate one or more breaks until we decide the asset needs to be replaced? And different utilities have different approaches. And in this insights page, we took a look at life expectancy from two different perspectives. The two cards on the left show the mean time to failure. And when we say failure here, we actually mean the actual end of life. So when pipes were actually removed from the ground or decommissioned. But then to see the wider picture, we actually need to look at that in combination with the patterns of breaks. So the graph on the right here shows breaks per 100 kilometers, another one of the KPIs that Martin mentioned before. And together, we'll see how this builds a much wider picture. So let's look at the smaller diameters where most of the breaks are happening. So if I filter to the 150 millimeters over here, I can see that the total mean time to failure is 36 years. So that's the average time to failure when pipes actually are removed and decommissioned. I can break that down into the different material types over here and see my AC and my cast iron, ductile iron, and so on. And if I look at the cast iron, I can see that the median year for replacement is 48 years. So cast iron has a slightly higher life expectancy of 48 years based on this data. And if I compare that with ductile iron, I can see it's 36 years. I have a very low number here for PVC, but that is only because the vast majority of our PVC have not yet failed. And those that have failed at very early stages, which can happen, but does not reflect, of course, the whole life cycle of PVC. Now, this is just one number. And as I said, to really understand the behavior of these, you need to look at the trend of breaks and how that changes over the years. And based on that, you can make more informed decisions. So let's select the cast iron pipes over here, and I've got it filtered to show only the 150 millimeters. So this chart, on the x-axis, I have the age of my water mains. So 20 years, 40 years, 60 years, and my y-axis shows the breaks per 100 kilometers. Looking at this data, we can see what we call for structural infrastructure, the bathtub curve, right? You have these premature failures at the top. You have a fairly consistent failure rate through most of the life. And then you have that spike towards the end of life. Now, if I look over here, we had a number of 48 as the median for the expected life. If I look into here, and I compare my trend to that 48 number, I might decide that I'm actually willing to let my cast iron 150 pipes stay in the ground a bit longer. Maybe I'm willing to leave them up until the age of 60, 65. And this really depends on the level of risk that I'm willing to take. There is no one date or status where you say this asset has failed. You can always keep fixing it and waiting for the next break to happen. But this allows you to carefully look at your data and, based on the level of risk that you're willing to take, decide, you know what, that's where I put my line, and maybe it's the age of 60. If I compare that to ductile iron, you can see that you need to draw that line at an earlier stage, right? We had the number of 36 over here. Maybe you can leave it until the age of 40 or 45 if you're willing to take that longer risk. Maybe even a few more years, right? And that depends on on your state of failure rate, current failure rate, and how much you need to improve or want to improve it based on your service levels. And if I add PVC into here, then you can really see why at the region there is a lot of success with PVC. You can see that much lower failure rate of the PVC record. So at the age of 40, we're looking at a failure rate of about 3.9 at the age of 40 per 100 kilometers, a much lower failure rate than what we are seeing with our cast iron and ductile iron, and this is not specifically for 150 millimeters. So these were three examples to answer three different questions. The first page was this overview of understanding, a wide understanding of which assets are failed and what technical and customer-related impacts we are seeing. The second page looked into the replacement program and drilled down into different cohorts to see the effectiveness of that program. And then that third page was really built to answer one very specific question, which is, what is the expected or the useful life? And I define what useful for me is for my different asset types by material and diameter. And with this, I think I will pass it back to you, Bill.
Okay, thanks, Chaim, and thanks, Martin. So, as we're coming to the end of the session, I just want to touch base back, and so we've come full circle today. We've seen how by collecting the right information in your maintenance management system and using the ArcGIS analytical capabilities, we're turning a huge amount of data into useful information. I think that's one of the key takeaways from today, is that I know many of you are collecting a lot of data. You know what you've done over the last couple of years, but are you turning that data into information, which is good management information to make the better decisions? And I think that's the combination of what Martin and Chaim have talked about, is all this massive amount of data, and now that you've been able to take the tools that are available and turn it into things that you can show to the citizens and to council how you're performing in the work programs that you've got. You can take a look at the failure rates that you've got, analyzing where you want to repair certain types of pipes and when, and the expectations of the life of those assets. And you've got to remember, we're using water as an example here, but you can use this for wastewater systems, facilities, roads, parks. The same concept applies to all areas of your asset and maintenance management operations. It's collecting the right data and then turning that data into useful management information. So before we get to questions, I want to mention a couple of items. You'll be receiving a copy of the slides, and we've listed where you can go to to get more information on what we at Esri Canada have done and can do to support you in moving to that next stage in your asset and maintenance management needs. We also want to take the time to thank you for attending today. You'll get certainly you'll get a copy of the recording. We also want to get your thoughts. There's a survey at the end of when you exit the webinar, and that's really going to help us in providing better webinars to you in the future. So if you have some questions, just follow these instructions here to ask the question, and we'll answer that. And at this time, we'll stop the recording because we're going to provide written answers to any of the questions.